My name is Kasper, lead platform architect at Lunar. If you're not familiar with Lunar, we do financial services. We are a bank. We have a banking license. So we try to disrupt the banking space, the financial services space. We are live in Denmark and Sweden and Norway, as it is right now, and expanding rapidly. Just hired like 500 people in 1 year, so it's going pretty insane.
You hired 500 people in 1 year? How I don't even understand how that's possible.
Me neither.
You must have an amazing team out there just headhunting.
Yeah, I think we do. It's not what I do, but I think that's an amazing team there.
And what percentage of those are engineers actually?
That's a good question. I think just in the 12 months, it's around 100 engineers.
100 engineers, yeah, that were hired. So your total engineer count is what?
I think it's 180 now. Yeah, 180.
80, yeah, 180, yeah. So Kasper and I are actually both. Well, I'm half from Denmark, but we're both Danes from Denmark. I think Kasper is originally from Aarhus. Is that right?
Yeah, that's right. Yeah.
We were both just at DevOps Days in Aarhus, where Kasper gave a great talk on multi-clusters, or sort of, would you say multi-cloud clusters, or would you say meshed clusters? I would say that's.
I think we can say both, because it was about multi-cloud, multi-clusters, and connecting them with a service mesh across. So yeah, multi-cloud, multi-cluster with service mesh.
We'll get a little bit more into that later in our interview, because I think if it's possible to do multi-cloud right, then Lunar is definitely doing it right. And a lot of the reasons why Lunar became multi-cloud was through a number of acquisitions. I wanted to speak, before we get completely technical, I wanted to speak because I'm actually a Lunar customer, and I know that Lunar Block was recently launched. Of course, as it so happens, I'm always late to the crypto party.
Me too.
So I made the very wise decision of investing some Danish crowns in the new Lunar Block product in Bitcoin, and watched as the markets just annihilated anything I put in. That was that happened recently.
Yeah, but hopefully it's going to go the other way again, right?
Hopefully. I'm holding. I'm not selling.
Yeah.
Can you, do you know, and maybe this is an unfair question to ask you, but do you know if, because I think one of the reasons why I wanted to try out the Lunar Block crypto product is that it would make my tax situation easier. Is that true? Like, does it auto-report to the Danish tax authorities so that you don't have to deal with it?
That's actually a really good question, because I think maybe we do have that functionality, but I'm really not certain. Unfortunately, I'm more on the platform side and doing Kubernetes and all that. So, but I think at least it makes it simpler, because you don't have to go through a lot of different exchanges now. You just basically put your money in, buy some crypto, and then you can take them out right away, directly to a bank account. So. It's the simple version.
Well, Lunar, if the rest of you are out there listening, consider this a feature request. I never want to file my taxes ever again, whether it's crypto or otherwise. Just let them take it from me, So let's get into the a bit of the technicals. Let's see, I did all these flashcards.
Looks interesting.
I color-coded them too.
Yeah, wow.
Here we go. Okay, so I covered our recent intro to crypto, our recent intro of the crypto product for Lunar. Next one's actually the multi-cloud strategy. So why don't we get into that? Before we jump in, are you doing a talk at this KubeCon?
I'm on a panel. So
you're on a panel?
Yeah, I'm on the Linkerd end user panel on Friday.
Which panel, sorry?
The Linkerd end user service mesh panel. Basically service mesh in production and our experiences with that.
Oh, interesting. So what does a panel involve at a conference?
So we are, so there's 3 other guys than me, and we just, discussing our use cases, our experiences, and just trying to, share what it's like to run Linkerd in production. That's sort of what we try to, elaborate and share our experiences about.
Yeah, cool. All right. Well, to that point, actually, maybe you can speak about how that journey's been for you. You mentioned, and this was really funny for me to hear, but there's a few. Okay, there's more than a few service meshes out there. Yeah, of course, the 1,000-pound gorilla is Istio, and then there's Linkerd. Actually, Buoyant, which is behind Linkerd, is I think the next booth over from us. Yeah, and they're actually friends of Garden. Hopefully, if things pan out, we'll have a chance to speak to the CEO of Buoyant, probably tomorrow if it happens, but no guarantees. So don't hold me to it. But I'll announce our speakers either this evening or tomorrow. But I worked with Istio a bit at a previous company, and it was honestly a nightmare for me. Something would always. It didn't really make sense. I felt like you needed a PhD in computer science just to understand like what was going on under the hood.
Yeah. So what we basically did was that we sat down two guys and saying, hey, we want to try this service mesh thingy, and so I was the one doing Linkerd, and my colleague did try to set up Istio, and yeah, that was actually the multi-cluster part. So we started out using basically the reason for adopting a service mesh in our case has been multi-cluster, initially at least. Then all the nice features comes afterwards, but multi-cluster was what tipped the scale for us. But what we basically did was sit down, you do this, I do this, we'll see how it goes. And I was like, so I had two clusters connected and services talking to each other in like an hour or two.
In 1 hour?
Yeah, something like that. It was super simple. And yeah, my colleague never finished because after 2 days or something, and he just, no. Why are we wasting time on this? Because we had this thing running and it working and it does what it's supposed to. And also the philosophy behind Linkerd is something that's really sort of speaking to us with, single responsibility, do the minimal, and just make the thing work. Then you can add stuff on top afterwards, right? Instead of doing the opposite around and building the entire thing from the beginning. So I really like that approach.
What can you describe the Linkerd philosophy a little bit for the audience?
Yeah, well, so they started out, doing the basics, figuring out that they needed to implement their own proxy to make things, go as they wanted to go. So just basically keep it simple and hide all the complexity away. That's, I think they are actually defining themselves as the simplistic service mesh or minimal service mesh. So that's basically, yeah, and that's just easy because service meshes are really complex things, and at least for us, it took a lot of years to actually get into to adopting a service mesh because we knew there would be a lot of complexity involved if we decided to go down that path. So
what were you using before service meshes to provide, let's say, mutual TLS and some of the other functionality?
Well, basically, we didn't have anything. So we were just basically using normal HTTP calls internally. So that was definitely also a thing that we wanted to do something about. Which we now have MTLS encrypted and all of that with the service mesh, because that was some of the features we got from finally deciding to move into service mesh. So the minimal approach, do the right thing, make it work, and then you can add all the nicer things on top. But just make sure that the communication is actually working and doing its thing, and yeah, you get the information you need.
So what can you describe some use cases of why you'd want to go multi-cluster, for example, at Lunar?
Yeah, so as you mentioned, we acquired a couple of companies last year. One of them is completely in Azure, and we are running everything in AWS, or was running everything in AWS. They are running .NET Core services in Azure App Services. And we basically needed to, so this company is going to be like very integrated with a lot of processes that we have, and a lot of services need to be able to communicate back and forth. So we needed a way to do communication across clouds. So how do you do that? And so just before all of this, we have experimented a lot with service mesh between AWS accounts and clusters there, because we wanted to centralize our log management solution, and they ran in different clusters. And yeah, we basically wanted to centralize all of that in one cluster. So that's why we started, doing multi-cluster and all of that. And then when we acquired this company called Lendify, it just made sense for us to start, spin up a cluster in Azure using AKS. .NET service or .NET Core service is fairly easy to move, so we could get them into the cluster. They could utilize all the tooling that we had already, so we built a lot of tooling ourselves, which we use internally for abstracting things away, releasing and all of that stuff. Because we really believe that the approach should be that we all have one way. We should be able to do the same, use the same flow and the same process across clouds. So if they could hook into our tooling somehow, then that would make everything a lot easier, and especially also from a compliance side, getting audit, getting all the information that you need, limiting dual lease privilege and all of that. So that was basically, I'm just rambling on here, but
That's fine.
but that's basically sort of where we started, and started to do it between AWS accounts, centralizing our log management solution. That worked really well, so we just applied that same pattern between Azure and AWS. Basically created a communication backbone.
But if you have a service in, let's say, on Azure, for example, and that's on an AKS cluster, and you have another service on an EKS cluster in AWS, I mean, are they they're actually speaking across to each other?
No, there's with Linkerd multi-cluster, you can link clusters in either one or bidirectional. But depending on how and which clusters communicate, so we have workload clusters in AWS, and we have one in Azure as well. They communicate in both directions, or can communicate, because you need to, as a developer, say my service should be exposed or sort of mirrored to the other side. So with Linkerd, you add an annotation on a service, a Kubernetes service, then that service will be mirrored to the cluster you're sort of specifying. We did some, it's not really the example, but you can, if you use some of the arguments to the Linkerd CLI, you can actually sort of define names of clusters. So we can say this service should only be accessible from that particular cluster in that cloud. So that's how we basically use it. And then Linkerd sort of handles the communication part, because it mirrors a Kubernetes service to Azure in this case.
Okay, so a service, for example, in EKS would be mirrored to Azure.
The Kubernetes service, so the resource, not the actual service, but the Kubernetes resource.
Kubernetes resource.
Yeah, so it will create a service on the other side. And then from whatever needs to talk to that thing, can just talk like normal, transparent Kubernetes with that service. Because it's in the mesh, and it just, Linkerd sort of abstracts everything away from you, and that's sort of what creates the connection.
That's fascinating. Oh.
It works really well. It's simple. It's Kubernetes native, because from the perspective of the services running in the remote cluster, they just communicating with another Kubernetes service. They don't really know it's a service on another cluster on another cloud. It's just a service. So it's super simple to actually do that. And it works really well.
That's really cool. Yeah.
So, maybe a small addition. So with the central log management solution, we tried to centralize the core platform capabilities, because we really believe that is really how we should do it. So log management should be central. You should have an observability stack running somewhere central, or buy a solution or whatever.
All right. Okay. So instead of, for example, running an observability stack on every single cluster, yeah, right. And I think it's actually what a lot of companies do. But you can just run the observability stack on an infrastructure cluster, right?
Yeah, exactly. That's what we do now. And now with Linkerd, we can just mirror the Kubernetes service in front of our log management solution and to whatever cluster needs to send logs. And then from those clusters, FluentBit is just collecting the logs and forwarding them directly to the Kubernetes service.
So all the logs hit the service endpoints that are mirrored, and then they get ingested into the infrastructure cluster. Yeah. Can I ask you, have you tried bringing in like crossplane, for example, for these infrastructure clusters? Because I remember, and it was your coworker Kenneth Foybeck, I think.
Phil.
Can it?
Yeah.
He did an amazing talk in Copenhagen, where he mentioned briefly that you can have brand new production clusters up without any fuss as soon as an old cluster is tainted or has been touched inappropriately. Like the point being is that nobody should ever be touching a cluster directly, and if they do, it's tainted. We deprecate it, and then a new cluster is spun up. How do you make it so easy?
So we spend a lot of time first.
Of course, I can imagine.
We actually spend a lot of time actually building we call it a failover. So we really want to practice and treat our clusters as cattle. Because what we learned, running Kubernetes for, I don't know, since 2017 is that it was really great moving from, VMs to now having a Kubernetes cluster, and we treat the cluster and the machines and applications as cattle instead of pets as we did before, right? But now our clusters sort of became the pets.
Now they have names.
Now they have names. So we didn't really sort of come anywhere because now we just have to do, So we really wanted to change that. And we started out adopting GitOps as sort of an initial step, because if you can remove the source of truth, put it in a Git repository, then it makes the process of restoring everything a lot easier.
You're using Flux for GitOps, right?
Yeah, we use Flux for applying our stuff.
Is there any reason why I actually run Flux at home for my own home lab cluster, and it works great. I love it. It's so easy to get started. I've always felt that Argo CD was like a little bit more intimidating somehow to get going. Was that part of the reason?
So I don't actually think Argo was an open source project back then when we started, but I think you can. And maybe this is I'm being honest, saying something that's unpopular now.
Okay, no, I want to hear the unpopular takes here.
but we talked about Istio and Linkerd, and I really think that Flux is like Linkerd. It's simple and it does whatever it needs to do. Where I guess Argo tries to do a lot more.
Right, absolutely. It sort of subscribes more to the Linux philosophy of do one thing and do it well, right? Yeah. Interesting. All right. So those easy failover of production clusters, how does it work technically? You don't have to go super in depth, but just sort of on a basic level. Yeah. You mentioned GitOps was involved.
Oh, yeah, sure. We spent some time on actually. So we have this tool called Shuttle. It's an open source project.
Right. Shuttle is an open source project. Maybe we can talk about that a little bit more.
Yeah. It's basically a way to create an abstraction on top of a repository. So it's just, you can basically view it as an extended or distributed makefile. So Shuttle has what we call a plan. A plan is just a repository containing stuff. And that plan also specifies some actions that you can run with a CLI. So I can say Shuttle run build, Shuttle run generate manifest or whatever. And those scripts are sort of coming from a central plan. So the key thing is we are able to centralize, templating for how should Kubernetes file manifest look like, Docker files. All of that is sort of centralized and managed by our platform team.
These Shuttle plan files, are they? Would a single plan file be within each repository, for example?
So the plan is actually a repository.
Plan is a repository. Okay, I got you.
Contains also a YAML file, of course, that specifies all the different actions that you as a developer can execute using the CLI. So what the CLI will basically just do is fetching this plan and run the commands from that repo. And that works really well because what we initially thought when we started doing microservices that all developers should do everything. They should run their own Docker files. They should, do their own Kubernetes manifest. But we just found out that is definitely not the way to do it for us.
No, writing their own Docker files, no.
Because what we ended up with was, patching. So whenever there's a, CVE or anything like that, developers were like, why? So it takes a long time, and they had more and more services. So yeah, it was just horrible for them. And we needed them to focus on actually delivering some features rather than patching all that stuff. So we actually centralize a lot of that, and that is what Shuttle sort of gives us.
But if you're not writing your own Docker files, how does a developer, let's say, check in their code to be turned into a container?
Yeah, so on a source repository, you have a shuttle.yaml file as a developer that basically defines which plan am I using, and then that project can fetch that plan. It knows how to build the Docker file because the Docker file is in the plan. So we sort of build in all best practices, sane defaults, all the stuff that they need, and then we created an abstraction for them to use, a simple one. So we really want to, hide all the complexity and just have them focus on actually building what they need to build, features for our customers. So that's what so this was Shuttle. We can use Shuttle for anything, so we also use it in the failover scenario, because then we can just abstract a lot of that complexity away. So we just have a command saying Shuttle run failover, and then a lot of different scripts goes on behind the scenes. It fetches our cluster definition, it spins up a new cluster. Then we have still some bash scripting going on there. That's something we're working on with Flux v2 to have like a dependency chain of how does the cluster need to boot. So whenever a cluster comes up, maybe we want like RabbitMQ running first. We want something else, something else, something else, and then services can just start up. So that's like this chain of dependency in the bootstrapping process. So that's currently a script today in sort of hidden away in this command.
And Shuttle is a completely open source product. Are you accepting contributions?
Yeah, sure. Sure.
That's the great thing about running. Is that you can really tap the community for to build a community around them. That's also what we're doing here at Garden with the Garden Core product. It's MPL licensed, totally OSS. As a developer advocate, I just really want to bring more people in and using it without any expectation. And if you want to contribute to either of these projects, it sounds you're open to it to making it a better.
Yeah. But if you want to know more about the failover process, my colleague has a keynote on Friday about this.
Oh, very cool. Okay, can you tell the audience a little bit more about the keynote?
Yeah, I think it's called Push It to the Limit, from Canary deployments to Canary clusters. So it's basically about how we did this, how are we failing over clusters, how do we want to do this on a regular basis, and sort of how it looks like some more technical step to step with a lot of visualizations of what is it actually we are doing. So it's basically, it highlights exactly what we want to talk about now.
Push it to the limits. What do you know what time it's on?
It's in the keynotes. It's in one of the middle keynotes, I think.
Okay. So if you're out there and you'll be attending us on Friday, make sure you look for Push It to the Limit, one of the keynotes happening on Friday, because if you want to stop treating your clusters as pets, and I know I do, then it sounds like a really exciting talk to attend. So this was the interview with Kasper Nissen, CNCF ambassador, and also the lead platform engineer at Lunar. So Kasper, I don't know if you know this, but we're actually doing a little bit of a giveaway for the audience, and I put it. They're supposed to listen for 2 words at the end of this interview, so I'm going to say them now. But remember, this is 6 baby houseplants that you can enroll in to win if you DM our Twitter account, the Garden Twitter account, the 2 words that I'm going to say now. So Kasper, it's been a pleasure. Until the next time we speak, and until then, contain yourselves.
Thank you.
So thank you so much, folks. I hope you